Welcome to this explainer. Today, we're tackling a massive headache in the software world, how to actually eliminate organizational friction and unlock a truly fast flow of change. If you've ever felt like delivering a simple feature feels like moving mountains, you are absolutely in the right place. We're going to look at how combining three really powerful frameworks can completely transform the way you build and operate systems.
But first, let me start with a question. Have you ever noticed that when you try to optimize just one highly skilled team, maybe your database engineers or your front-end developers, it often entirely fails to improve the actual delivery speed of your product? You might make that one functional silo incredibly fast, sure, but the overall project still drags. Well, this is what we call the local optimization trap. Improving just one separate part of a system simply won't fix your entire delivery pipeline.
Okay, let's dive into this with a brilliant quote from Dr. Russell Ackoff, a real pioneer of systems thinking. He stated, "A system is more than the sum of its parts. It's a product of their interactions." So what does this all mean? It means the way these parts fit together dictates the performance of your system, not how they perform on their own. If we ignore how our teams and software components interact, our efforts to improve them are, honestly, doomed to fail.
And that brings us to a really crucial comparison. When we build systems, we face two main challenges, right? Building the right thing, which is all about effectiveness and generating actual business value, versus building the thing right, which is about efficiency, like tuning our engineering practices. You absolutely need both. But as Dr. Ackoff pointed out, executing the wrong strategy with perfect efficiency is still a failure. We need a holistic view to align our business strategy with our architecture and our teams.
So here's our roadmap for this explainer. 1. The local optimization trap. 2. Mapping the business landscape. 3. Defining clear system boundaries. 4. Team topologies for coordination. 5. Evolving the legacy system. And 6. Architecture for fast flow. Let's get into it.
Section 1. The local optimization trap.
Picture a fictitious online school running on a legacy system, completely supported by heavily siloed traditional teams. You've got a database team, a front-end team, an infrastructure team. They're dealing with what software engineers lovingly refer to as a big ball of mud, and it's exactly as messy as it sounds, like a giant plate of digital spaghetti. Because they're broken into these functional silos, every single release requires massive communication and coordination efforts across teams. We're talking endless handovers. The software model is messy, the boundaries are completely fuzzy, and no one actually has clear ownership. This leads to incredibly high cognitive load for the developers. It takes massive effort just to understand a single piece of code.
Section 2. Mapping the business landscape.
So how do we fix our online school? Well, we need to look at the broader environment using Wardley Mapping. This visually plots your organization's landscape. On the y-axis, you have your value chain, starting with your users, like teachers and students, and their specific needs, like creating course content. On the x-axis, you plot the evolution of the components needed to meet those needs. Everything evolves from left to right, starting from brand new Genesis, over to custom built, then to product and rental, and finally ending at commodity and utility. This map gives your teams real situational awareness. It basically tells you that you should build your competitive differentiators in-house, but you absolutely have to stop wasting effort custom building commodity infrastructure, like a standard message broker or basic virtual machines. Moving on to Section 3, defining clear system boundaries.
Now, what's really interesting about this slide is how it forces the business to be totally honest about what actually matters. We use domain-driven design, or DDD, to break the problem space down into subdomains. You have your core subdomains. These provide your competitive advantage, they're highly complex, and you definitely must custom build them in-house. For an online school, that'd be the custom course creation. Then you have supporting subdomains, which are much simpler, like basic student evaluation. And finally, generic subdomains, like user login. Everyone needs a login, but it doesn't give you a competitive edge, right? You should just buy or outsource those generic parts.
Once you've identified those subdomains, domain-driven design helps you define what are called bounded contexts. You can think of these as modular software components where a single, highly specific domain model lives. And here's the secret. These bounded contexts serve as absolutely perfect, crystal clear ownership boundaries for your teams. They restrict a model to a very specific boundary, which prevents that messy, fuzzy overlap that causes so much friction and delay between teams.
Section 4. Team Topologies for coordination.
To actually build this out, we must adopt team topologies for better coordination. It all starts with the primary team type specifically designed for flow, the stream-aligned team. These are cross-functional, fully autonomous teams aligned directly to a continuous stream of work, like one of those core bounded contexts we just talked about. They have complete end-to-end responsibility. They design, develop, deploy, and operate their system. The ultimate goal here? Zero handovers to other teams.
But look, a stream-aligned team can't do it all alone without burning out. That's why this framework introduces 3 supporting team types whose sole purpose is reducing the cognitive load of those stream-aligned teams. First, you have platform teams that abstract away all that messy infrastructure into easy-to-consume internal services. Next, you have enabling teams that actively coach and bridge capability gaps. And finally, you have complicated subsystem teams for highly specialized, really difficult knowledge areas.
And this brilliantly illustrates that just grouping people isn't enough. We have to actively prevent chaos through strict interaction modes. Collaboration is for when teams are working closely together for rapid discovery and innovation. X as a service is used when a streamlined team just needs to predictably consume a tool from a platform team without talking to them constantly. And facilitation is for when an enabling team is actively helping and coaching another team. By adopting these specific topologies and interaction modes, you radically improve coordination and keep the flow of work moving fast.
Section 5, Evolving the Legacy System. So we don't just go in and blindly rewrite code. We use a team-first approach. Step 1, we take members from our online school's old back-end and infrastructure silos to form a brand new platform team. Step 2, that platform team steps up and closes the organization's efficiency gap by replatforming the clunky on-premise infrastructure directly to the cloud. Step 3, once that platform is ready to go, we form new stream-aligned teams to start incrementally refactoring that big ball of mud into those clean, DDD-bounded contexts we defined earlier.
This transition requires what we call dynamic reteaming. It's important to remember that the relationships between these new teams are absolutely not static. When the stream-aligned team first starts refactoring, they work in a close collaboration mode with the platform team to discover the right cloud tools. But as those tools become mature and stable, the interaction naturally shifts to X as a service. The stream-aligned team just consumes the platform seamlessly. This evolution of interactions is exactly what preserves fast flow over time.
Section 6, Architecture for Fast Flow. So the crucial point is this. Combining these frameworks creates an incredibly adaptive socio-technical system capable of absorbing change gracefully. By layering Wardley Mapping for business strategy, domain-driven design for software boundaries, and team topologies for human coordination, we've achieved the flow state for our online school. We've totally eliminated those painful functional silos and handovers. We now have clear domain models with loose coupling. The cognitive load on our developers has been drastically reduced because they only own what they can handle, and we've confidently outsourced that commodity infrastructure to the cloud. Which leaves us with one final thought to ponder today. Take a hard look at your own organization. Are your boundaries and team structures intentionally designed to empower a fast flow of change? Or are you just managing the messy symptoms of a big ball of mud? Thank you so much for joining me for this explainer. I really hope this gives you a powerful new lens to look at your architecture.